Hi, this is Dr. Karthik, and today we are just going to discuss the mathematical modeling of systems. And today's lecture series, we are just going to see two important systems. One is the mechanical system, the other one is the electrical system. So, mechanical system, before moving into the basic elements that form the mathematical model for a mechanical system, I've just shown you an example of the suspension system in an automobile car. So here the whole mass of the car is shown by M1, and then the spring, the suspension, it is shown by the spring and a dashpot, and finally the wheel, everything. So this totally form, you can see the coil spring, the damper, that's nothing but a piston moving inside a cylinder, and the whole mass of a body. So this represents basically the active vehicle suspension system, now which forms the basis for the mechanical system. Therefore, the three important elements of a mechanical system are mass, dashpot, and a spring. So in order to model the mechanical system, now if a force is applied to a translational mechanical system, then it is opposed by opposing forces due to the mass, elasticity, and friction of the elements of a mechanical system. Now, according to our Newton's law, now since the applied force and the opposing forces are in opposite directions, the algebraic sum of forces acting on the system is zero. Now, this is the basic rule for forming the mathematical model for a mechanical system. Now, the first element what we are going to discuss is the mass. So the mass is represented by a letter M, and F, it is the applied force. Now when a force is applied to the mass element, it moves a displacement x. So therefore the force that is due to the mass element is directly proportional to the acceleration a. So when we equate this proportionality, now we get an element that is m, which is nothing but the mass of a system. So therefore the force due to the mass element, it is represented as Fm, which is m into d squared x by dt squared. Now again, before that is our previous definition, that is the opposing forces is equal to the applied forces. Therefore we get the force m as m into d squared x by dt squared, where F is the applied force, Fm is the opposing force due to the mass, m is the mass of the body, a is the acceleration, and x is the displacement. So this, it is the first element, that is the mass. The second one is similar, that's nothing but the spring, which is represented by K, and again when a force F is applied, now the spring elongates and it moves displacement x. Now here again force is directly proportional to x, and when you equate the proportionality, now we get K is equal to K into x. Now when you equate the applied force, that is Fk is the opposing force due to the spring K. Now when you equate it, that is by applying Newton's law, we get F is equal to Fk, which is Kx. Now where F is the applied force, Fk is the opposing force that is due to the elasticity of the spring, K is the spring constant, and x is the displacement. And final element, that is the dashpot, again which is nothing but a piston moving inside a cylinder, and B is the viscous coefficient. Now when force F is applied, now this piston, it moves by a displacement x. Again the opposing force due to the dashpot, it is directly proportional to V. So when you equate it, we get B, that is a constant which is called as the frictional constant, that is coefficient. And by applying Newton's law, now we get the applied force F is equal to the opposing force Fb, which is B into dx by dt. Now again here, F is the applied force, Fk is the opposing force due to the friction, B is the constant frictional coefficient, V is the velocity, and x is the displacement. So these three elements form the basis of the mechanical system, that is modeling of any mechanical system. Now we just put together, now I have just shown you an example of all three elements acting together, and in order to find the final transfer function, that is output by input. Output is the overall displacement that is given by x of s, and input is nothing but the applied force f of t, which is given by f of s. Now this concludes the modeling of the basic mechanical system. Now the next very important system what we are going to discuss is the electrical system, and here the resistance, inductance and capacitance. Now these three elements are the basic elements of any electrical system, and here I've just given the relationship between the voltage and current for the electrical system. Now you can see for a resistor your voltage VR according to Ohm's law it is I into R, and we have it is the dissipative element, whereas the inductance and the capacitance, they are the storage element in terms of magnetic energy and electrostatic energy. Now VL, that's the voltage across your inductance, it is given by, that is L into DIL by dt. Now this is the relation between voltage and current for an inductance. And similarly Vc of t, that is for a capacitance, it is 1 by C integral IC of dt. So now these three elements form the basis of any electrical system. And here for a simple RLC network, by applying Kirchhoff's voltage law, here again in mechanical system we go with the Newton's law, in electrical system we go with the Kirchhoff's law. Now we can find the transfer function of the system. So this concludes the basic modeling of any mechanical and electrical system. Thank you very much.